Okay, so we have this interesting equation here, and we are not going to be solving this equation graphically. We are going to be using a rigorous algebraic approach involving the Lambert W function. So we are going to just try our best to rewrite the equation and make sure that the left-hand side or the right-hand side is in this form, and this W here is the product log from the Lambert W function. And of course, from this equation here, we know that the product log of x e to the power x must simplify to x. So just like you have product log of 2x e to the power 2x also simplifies to just 2x. So the product log simplifies this. Since notice that the power for e is 2x and the coefficient is 2x, so the product log simplifies everything to just the 2x, just like how it simplifies this to just the x. So let's go straight to the problem. So remember that our aim here is to make sure or resimplify the equation in such a way that we are going to get this form on the left hand side or on the right hand side or both sides in any way. So you have to be very careful. Your background knowledge of indices, algebra will play a vital role here. So let's go there. So I can rewrite the equation. I'll move the plus x to become minus x on the right hand side. So I just have 2 raised to the power x equals 37 minus x. And then I can divide both sides by 2 raised to the power x. Or let me just rewrite the equation to 37 minus x equals 2 raised to the power x. Still the same thing. So now I can conveniently divide both sides by this 2 raised to the power x. So divide here by 2 raised to the power x. And also divide everywhere here by 2 raised to the power x. So this cancels this. I'm left with 1 on the right hand side. And then I can rewrite the left hand side as 1 over 2 raised to the power x times the 37 minus x. If you multiply this term with this term, you get back this one. So this is the right thing to do. Then equals 1. And then on the left hand side, I can rewrite 1 over 2 raised to the power x in negative index form from the laws of indices. So I can write 1 over 2 raised to the power x as 2 raised to the power minus x times 37 minus x equals 1. I can swap them since they are commutative. So I can write the 37 minus x first, then times the 2 raised to the power minus x second. Doesn't change anything. If you multiply both of them, you get the same thing. This is commutative property equals 1. And from this equation, I can rewrite my 2 raised to the power minus x in terms of e. Don't forget that if you have e to the power ln of a, you have a. So I'm going to write 2 raised to the power minus x in terms of e. So it becomes e raised to the power ln of 2 raised to the power minus x. So let's do that. So I still have my 37 minus x times, then here I now have e raised to the power ln of 2 raised to the power minus x, then equals 1. Then from laws of logarithm, the power for 2, which is minus x, can come over here. So we now have 37 minus x. We now have e to the power ln of 2, and then the minus x comes here. So minus x, we're still on the right track, equals 1. And then our aim is to make sure that we have the equation in this form, the left hand side, and we are almost there. We have our e already, but we have minus x ln of 2 here. We need to have something similar here, or we just need to make both of them the same, the power and the coefficient, and we are almost there. So we still have some more manipulations to do. So we can multiply the left hand side and right hand side by ln of 2, and let's see where it leads us. So multiplying here by ln of 2, I now have 37 minus x times ln of 2, then times, I still have my e raised to the power minus x ln of 2 then equals to, I have 1 on the right hand side, so ln of 2 times 1 still gives me ln of 2. So successfully I've multiplied ln of 2 on both sides. So I can open the bracket here, so I can say ln of 2 times 37 gives me 37 ln of 2 plus times minus minus, then ln of 2 times x gives me x ln of 2, then everything times my e here, still there, e minus x ln of 2 equals to, I still have ln of 2. Then going further, the main issue here now is trying to make the power for e to be the same as what I have here, 37 ln of 2 minus x ln of 2. That's the issue now. So what I will do here now is to take a good look at this part of the left hand side, e raised to power minus x ln of 2. I can multiply both sides by e raised to power 37 ln of 2. So let's see what it leads us to. So I have 37 ln of 2 minus x ln of 2. Then I have my e minus x ln of 2 times e raised to power 37 ln of 2 equals to, I'll do it on the right hand side too, ln of 2 times e raised to power 37 ln of 2. Then from the laws of indices, if I multiply these two, I pick one power and then add up one base rather, pick one base and add up the powers. That will be minus x ln of 2 plus 37 ln of 2. And then we still have this one here waiting for us, 37 ln of 2 minus x ln of 2, then equals here. If you simplify this from this rule here, gives you, remember that e raised to power ln of a gives a, so it means that this just simplifies to just 2 raised to power 37. So I now have 2 raised to power 37 times ln of 2. So this simplifies to 2 raised to power 37 here, and of course I still have my ln of 2. They are still in product form. So continuing, finally this power and the coefficient are now the same. So this is what I want. I have minus x ln of 2 plus 37 ln of 2. Here I have minus x ln of 2 plus 37 ln of 2. I can now apply the Lambda W function on the left hand side, but I need to have the same form here too to make my work easy. So successfully we have this form on the left hand side. I need to have this form on the right hand side also. So let me now focus on the right hand side and manipulate the right hand side also. So the left hand side, I still have 37 ln of 2 minus x ln of 2 times e raised to power minus x ln of 2 plus 37 ln of 2 equals 2 raised to power 37 can be written as 2 raised to power 5, 2 raised to power 32 rather, times 2 raised to power 5, then times ln of 2. It is possible, following laws of indices, 37 is now written in separate forms as 32 and 5. If you multiply this, you pick one base and add the power, you still get this back. So I'm on the right track. So I can still further manipulate this again. Rewriting the left hand side, I still have my 37 ln of 2 minus x ln of 2, then e raised to power minus x ln of 2 plus 37 ln of 2 equals, this is now 2 raised to power 5 is 32. So I now have 2 raised to power 32 times 32, then 32 times ln 2, that's 32 ln 2 or ln of 2. And we can now have it this way. I can rewrite 2 raised to power 32 in terms of e. Again, don't forget in terms of e here. So this now becomes e raised to power ln of 2 raised to power 32. Yes. So this now becomes this. Then I still have my times 32 ln of 2 there waiting for me. I'm still trying to make sure I manipulate this to be in that product log form I showed you. So rewriting the left hand side, I still have my 37 ln of 2 minus x ln of 2 times e raised to the power minus x ln of 2 plus 37 ln of 2 equals to what we have here on the right hand side. So going further, let me put this one first and this one second. And of course, the power for 2 can come over here. So I just have e raised to the power 32 ln of 2. And of course, I still have the 32 ln of 2 here. 32 ln of 2 then equals to exactly what I have here on the left hand side. So I still write out my 37 ln of 2 minus x ln of 2 times e raised to the power minus x ln of 2 plus 37 ln of 2. So finally, I can apply the Lambert W function on both sides because I have successfully established this form here. So take note, I have my e and the power and coefficient are the same. So the power and the coefficient are the same on the left hand side. Bravo. Then on the right hand side, the same thing, I have my e and then the power and the coefficient are the same. So I can apply the Lambert W function on both sides. So let me do that now carefully. So apply my w on both sides, w into 37 ln of 2. I have to squeeze that in, minus x ln of 2, then times, let me put a smaller bracket, times e minus x ln of 2 plus 37 ln of 2, then close the bracket, equals to, apply the same rule here, the Lambert W function or product log of 32 ln of 2 times e raised to the power 32 ln of 2, close the bracket. And of course, the product log of all these simplifies to one of them since they are the same. So this product log of what I have in the bracket simplifies to either the power or the coefficients. So let me write this one out, or this one out, any which way, still the same. Minus x ln of 2 plus 37, this 37 ln of 2 equals to, also the product log of what I have in the bracket simplifies to either the power or the coefficient. So I'm just picking one of them, simplifies to 32 ln of 2. So collecting like terms, I'm moving this plus 37 ln of 2 to the other side, leaving minus x ln of 2 here. Ln of 2 equals 32 ln of 2 minus 37 ln of 2. So I'm left with minus x ln of 2 equals to 32 ln of 2 minus 37 ln of 2 gives me minus 5 ln of 2. So ln of 2 cancels out. I'm left with minus x equals minus 5. And again, the minus and the minus cancels out. I'm left with x equals 5. So x equals 5 is the key answer to that equation. So that's it.